Now, today we'll talk about vectors. And before talking about vectors, I want to remind you of something with grade 10 that we took before, properties of vectors. Number one, in vectors, if we have a vector going that side, okay, if the same vector goes on the other side, that's a negative A, which is on the, just switching the sides 180 degree, that's a negative A. Number two, in vectors, if I have 3 points, let's say A and B and C, if I told you, find me AB, you will go directly from A to B in this way. You will go directly from A to B. Like in vectors, it means that find me another way from A to B. So you have to go AC, then CB. Okay, so that's an AC plus CB. Now in vectors, number three, if we have two parallel vectors, if this is, let's say, A plus 1 over 3B, and if the other vector is 2A plus 2 over 3B, we say, let's say that's AB and CD and CD. And so we say that the vector AB is parallel to the vector CD because one of them is multiple of the other. And if we multiply 2 times the vector AB, we will get CD. If one of them is multiple of the other, so we say that the two vectors are parallel. Number four, if we have, let's say, A and B and C, and if AB was, let's say, 2A plus 2 over 3B, and BC was A plus 1 over 3B, as AB is equal to 2 times BC, one of them is multiple of the other. So we say that ABC lies on a straight line, or ABC, they are on a straight line, one line passing through 3 of them, if one of them is multiple of the other. And there is a difference between parallel, multiple of the other, lies on a straight line, multiple of the other. Here we have 3 letters. They are connected with the point B. Okay, but for parallel, we have 4 letters. In this way, we can tell if they were parallel or lies on a straight line. Now, I'll talk about ratios and vectors. If I have, let's say, AC and B somewhere here, and if, let's say, AC was given by, let's say, for example, 2A plus 3 over 4B. That's your full AC. And if I say the ratio AB to BC is given by the ratio, let's say, 3 to 2. As you can see, the whole AC over here is divided into 5 parts. As this is 3 from AB, that's 3 shares and 2 shares, so 5 shares. So this AC is divided into 5 shares. Now we say that AB is equal to 3 out of the 5 shares of AC. It means that 3 out of 5 times AC, that's a 2A plus 3 over 4B, and which is equal to 6 over 5A plus 9 over 20B. That's your AB. Now, if we need to find BC, the BC is 2 out of 5 of AC. That is multiplied by AC, which is 2A plus 3 over 4B, which is equal to 4A over 5 plus 6 over 5B. Okay, now the ratio may come in different ways. It could be, they may say in the question, AB to BC is equal to 3 over 2. They may they may give the ratio in this way, or they may say, they may do cross multiply. They may say 2AB is equal to 3BC, or they may say AB is equal to 3 over 2BC. In any form it's given, we have to take it back as a ratio so we can understand how to deal with it. For example, if in the question, the same example, and like in the ratio, they have said AC to BC is 5 to 2. Now, in the first example, it was part to part, AB to BC. In the second example, the ratio given AC, which is whole to part, that's a 5 to 2. So calculation will not be different, because AB has AB has 3 shares out of the 5 shares, because the whole AC is 5 to 2, so we have 5 shares for all of the total of the segment AC, and here we have 2 shares, so that's a 3 share, and then we can do the calculation as we used to do. Okay, now I will continue recording the I will use the presentation. Wait a minute. Now, vectors M1 presentation. We will talk about vectors and specify how vectors work. In this chapter, we will learn about vectors, and we may use Sabat equations in vector questions, sometimes using vectors alternative methods. We have different alternative methods. Now that's made for the old chapter, old syllabus, but the content's still the same. You can use vector to describe displacement. Vector has both direction and magnitude, as you know. Now an object is moving, for example, north at 20 meters per second. That's the vector velocity, 20 meters per second. So a horizontal force of, let's say, 7 Newton. An object has moved 5 meters to the left. So there are all vectors. Those are all vectors. The vector has magnitude and direction, as you know. So a scalar quantity would be something such as force 10 Newton, that's a 10 Newton. 7 Newton, for example, that's a force. The vectors has both direction and magnitude. That's moving north at 20. The horizontal force is 7. It's only magnitude. Okay. You can use vector to describe displacement also. A girl walks 2 kilometers due east from the fixed point O to A, and then 3 meters due south from A to a point B. Describe the displacement of B from O. Okay, that's vector question. We have shown this in the beginning of the of this video when I said A, B, C, 3 points. And first of all, let's draw the diagram. First of all, goes from 0, walks 2 kilometers due east, means strictly to the right, from a fixed point O, then due south in this way. So the displacement. Now, describing the displacement. The distance, use Pythagoras theorem so we can find out the hypotenuse by using Pythagoras, 2 squared plus 3 squared square root. In this way, that's your C. The bearing, we use trigonometry to find the angle theta, which is this one. Okay, so we have to tell the bearing for the north. Now tan, then we do tan inverse, that's a 53.3. So the bearing are measured from the north. and the north line to the, because here we have the north is coming from this point to that point. That is your north. Okay, so this is the north, and as you can see, that's a 90. So we can say add 90 to this. That's a 46.3 degrees on a bearing of 146. So in this way, we can tell from the north, we can tell it's about to be 146 on a bearing of 1. So point B is 3.61 kilometers, as we found it here, on a bearing of 146. Now this is the way how to describe the how vectors work. Now we have another exercise over here. Just let me prepare it. Describing the displacement of S from B. Start with the diagram. First of all, let's draw C, S 15 kilometers away from A. Then that's a bearing of 120, as they are saying. Then 9 kilometers on a bearing of 240 to the second checkpoint from A, from the point A. Means that, let me just show you what they mean by this. At the point A, what comes after from is your starting point, and we draw the north. So the whole thing over here is equal to 240. 240. Now checkpoint from B, and then returns directly to S. Let's continue the question. Directly to S, that's 240. Then we need to find, the distance B from S. So we can find out in the bearings, if you know that in math, if those two lines are parallel, those two angles, they add up to 180. They are allied angles, so we can find this angle, that's a 60, then we can find this angle in the middle, then using cosine rule to find the values of x. Let me continue the presentation. By using cosine rule, we can find the value of A. Okay, find the bearing from B to S. From, what comes after from is your starting point where you will draw the north. So from B means at B we will draw the north, that's the north. Then find the bearing from B to S means that north will go to the right up to here. We need to find this angle. Now this is the bearing that they need me to find. Okay, let me continue the presentation. Now those two sections, this is not equal to this. It's not necessarily to be equal. Now we need to find the angle theta inside the triangle. So we may use the cosine rule because we have 3 sides over here, or sine rule, as you know. Substitute the values, then we got the theta, which is equal to 36.6. You can now alternate angles. Now we have a north and a north, the 120 plus 36.6, and then we can find this angle by subtracting from 180. Okay, now you can add and represent vector using line segment. Vector can be represented as the directed line segment. Two vectors are equal if they have the same magnitude and direction. Now two vectors are parallel if they have the same direction. So 3a is because one of them is multiple of the other, they are parallel. When we add vectors, we say that from A to C, find me another way from A to C, that is AB plus BC. This is what we were talking about. Parallelogram, now the points are there, midpoints are P, Q, M, N are midpoints. If this is a small a, OA is a small a, so that's half a, and this is half a. Let me continue, find the rest of them. Now if this is a half a, and that's a half a, any vector parallel to OA is also half a, and then that's a half a. And because this is a b, this is half b, and this is half b, and of course this is half b and half b, and also half b and half b, and also this is half a because they are all parallels. Half a. Find OC. OC is the line which passes from, means find me another way from O to C. Find me another way from O to C, so we'll say B plus A, that's your, for example, if I want to find Qn, okay, Qn, and direction is important, that is Qn. If you are going that side, that's NQ. So Qn is, because the direction of those vectors is QC plus, so that's QC, that's a half B minus, because the direction is switched, half A. Okay, so let me go for the other example. All of those is given. No, for triangle, M is a midpoint, OA is a divided the ratio into this. That's a midpoint, that's a ratio. Okay, that's a small a, that's a small b, and express ON in terms of AB. In vectors, usually we used to find everything before solving the question. So if this is small a and that's a midpoint, this is also a small a. This is the ratio 1 to 2, means the AB is divided into three parts. It means that AN is equal to 1 out of 3 of AB. And that's your A and that's your NB. So first of all, let's find AB. AB, find me another way from A to B. So AB is AO plus OB. Means AO, that's a negative 2A plus single B. So when I say 1 over 3, that's a 1 over 3 times negative 2A plus B, which is equal to negative 2 over 3A plus 1 over 3B. So that's your AB. So now finding ON, find ON means that we have AN already found. That's yours. So ON is equal to OA plus AN. So that's OA, that's a 2A plus negative 2 over 3A plus 1 over 3B, which is equal to, that's a 1 and 1 over 3A plus 1 over 3B. So this is the way how to calculate in vectors. We have to find, now, yes, we have expressed. Let me just erase what I wrote so I can continue with the question and the other slides. Okay, parallelogram, then the points. This is the parallelogram and it is sketched in this way. Now, when we start, they need try to find a way to present OP. OP, yes, OP, if this is a big C, if this is a big C and the small a, small c, so this is also a C and this is also an A, so OP is given OP, that's a C plus A, and that point is the midpoint, so OP is half of this, which is half of C plus A. Okay, now you can describe vectors using the I and the J notation. Now a unit vector is a vector of length 1. Unit vectors along Cartesian x and y axis are usually denoted by I and J. Now this is the unit vector on x-axis, unit vector on y-axis, that's represented by I, that's represented by J. If we have a vector, for example, AB on the x-axis 5i and BC on the y-axis 2j, so we say that AC, we can do it in this way, that AC is 5i plus 2j. Okay, now draw the diagram to represent the vector negative 3i on the x-axis plus 1j. So that's a negative 3i on the x-axis negative and 1j upwards. So that's the negative 3i plus j. You can solve problems with vectors writing using ij notations. The vector are written in terms of the unit vector. Given that, for example, that's your p, that's your q, and find p plus q. Of course, we will add the x's together, the y's together, and then we will get one unit vector, which is 7i plus 4j. Now, when a vector are written in terms of the unit vector I and j, you can add them together by adding terms I separately. Subtracting also works similar way. This is the way how to find the addition and multiplication. We may do this in this way. When a vector is given in terms of unit vector I and j, you can find the magnitude by Pythagoras theorem, of course. The magnitude is the 3 squared plus the magnitude of this vector is 3 squared plus negative 7 squared under square root, which is the same as Pythagoras. Okay, you can also use trigonometry to find the angle between vectors and the axis. We may use this, the vector and the x-axis. This is the vector, and that's theta, and we may use tan to find the angle 51. The angle we want between the vector and the positive x-axis subtracted from 180, of course. That's a 127. You can solve problems with vectors written by using this I and j notation. Now, if A plus mu B is parallel. When I say parallel vectors, means their gradient is the same. Now, the gradient of the vector is coefficient because this is the y-axis. This is the x-axis. Now the gradients should be the same. So the first vector can be written as, if we plus them, that's your A, that's your B, and we make mu subject to it, we make mu outside. So separate them, make the I and the J separately. This is your I, this is your J. As they are parallel, means the I terms must be 3 times the J terms. This is the I term, and this is the J term. Okay, so this implies that the 3 times, we say multiple vector is a multiple of the other one. So 3 plus mu equals to 3 . So, or we can say the gradient, we may say the gradient of this vector, that's a -1 plus mu the y's divided by the x's plus mu is equal to the y's 1/3. You can cross multiply to get it in this way. So let me continue. So the mu is equal to 3. To show that this works, we substitute the mu we got, which is one of them is the multiple of the other multiplied by 2. Now you can express the velocity of a particle as a vector. Now velocity has direction and magnitude. So that's a velocity. Now the speed is the magnitude, and the distance traveled moved for 4 seconds. So the 3I, they're finding the speed of a particle magnitude. So the speed of the particle is the magnitude of the vector. The velocity, which is, that is the speed. Now find the distance traveled every 4 seconds. As you know, the distance equals speed times time. All you need to do is to multiply. Okay. Now you can solve problem involving velocity, time, mass, and force as in area by using vector notation. If a particle starts from the point with positive vector or not. Now I'll stop over here for the next lesson. We will do this together, inshallah.